All right, let me turn this on. Thank you guys all for sticking around. We're almost at the end point, penultimate session here. Again, I have my PDF of this up on the website if you want to grab it to follow along. I also have just the code that I'll be running if you want to play with it. I didn't make a notebook because there won't be too much going on within the terminal for any of this. But the idea for this session was to do something a little bit different. You've heard a lot of scientific computing stuff today. You saw some nice work that James showed you just before that's actually relevant to his research. But I'm going to give you a slightly different perspective on how science is done. This is from a postdoc perspective, if you will. And so also, hopefully, you'll learn a little bit about how you can use Python, not just for things like data manipulation, but how to interact with the outside world. So we'll talk about how to talk to websites in an automated manner with Python, in particular using these three modules. It's a little bit about relational databases using this one particular formulation called SQLite 3. So sending some basic email, again, all from Python scripts. And at the end, we're going to write a short Python script called Do Science. Okay, that's the output of this. So this is my somewhat biased perspective as a postdoc here at UC Berkeley on how science gets done. You should know I'm an astronomer. I'm going to use a few astronomy-related words, but I don't think that will obscure the meaning for any of this. So usually I'm sitting around, working hard at my desk, and I get an email like this. Comes from some professor. It's got a subject saying supernova, which for all intents and purposes, some interesting astrophysical source that's not going to last forever. We have a finite time window in which we can actually observe this thing. It says, "Dear Brad, please arrange for further observations of this interesting source. I'm busy teaching or traveling or sitting on the beach. Thanks from your favorite professor." And then, of course, there's the sort of threatening, "I'll get you a recommendation letter as soon as I can," so you're really extra motivated to actually go out and do the work. So, I have a couple choices at this point. I could actually really try to put some time and effort into actually finding out what's going on. Is this thing really interesting? What are the best resources we have to observe this? Or because I'm very fortunate in that I'm not really the sort of lowest tier of the totem pole, there are fortunately graduate students below me. I can get them to do the work for me. So we're going to write a Python script called Do Science here. It's going to extract some additional information about this source from a web page. Just a short, simple one that I created for this. We're going to select a random graduate student from an SQLite database in the astronomy department, and we're going to send them an email to ask them to do the actual work. Okay? Simple, straightforward. Hopefully you'll learn a little bit about interacting with the outside world in Python. Connecting to the internet, the two modules that are very commonly used for this are called URL-lib and URL-lib2. Both of them provide access to any uniform resource locator. URL-lib is more or less deprecated at this point. You really only, unless you're doing sort of very specialized things, be working with URL-lib2. And OpenURL, again, is this sort of very simple command. You'll feed it as an argument a URL page you want to grab, and it will retrieve that information, assuming you're connected to the internet. So here's a simple web page that I created. The URL is, again, at the top here. It has a list of recent supernovae, objects of interest, something about information about them in this little simple table, like where they are in the sky, what galaxy they occurred in, something about the type of object that they are. This is what the HTML looks like. We'll have to go into this just a little tiny bit. I assume most of you, raise your hand if you've never seen like HTML, the actual text code of that before. Okay, so there's still a few of you. But basically, what your in order to generate this, your browser looks through this sort of ASCII text file and looks for these things called tags, which are indicated with these caret symbols. Every time it encounters one of those, it tells it to do something interesting. For example, here, this H2 tag at the top tells it it's called a heading of size 2. That's going to give you some bold. Everything that's in between those tags is going to be shown in bold. And you can see there's a table tag that tells it it's going to make a little table. TR is for each row in the table, TD is for an item, a column within that row. So we're going to write a simple script to grab this full HTML file from the web server on which it's hosted, run through it, and retrieve the information that's in this HTML file. So the first part is extremely simple. URL, I said you're going to use this URL open command. So within the URL lib2 module, this is the actual URL that we want to retrieve. Literally just a couple lines of code, URL open, the name of the URL. This returns a file-like object. It's exactly like if you were to open a file that's located on your own machine. Okay? So what you're probably going to want to do is then read that file-like object, and then this S that you have here is just a long string that has all of this text from start to bottom contained within. Okay, and then if we want to be very nice, we can close, free up this memory, and that's it. We've retrieved all the information that's on this web page. Okay, again, it's not an extremely useful format. That's where a bit of the more interesting coding comes in. But it's literally just a couple lines of code to say, grab a web page, give it to me in a string format. But now we need to what's called parse it. We need to go through, see what all the tags say, see how they're structured together, get some useful information out of that. There are several packages within Python that do this. The two most popular, one of which is called Beautiful Soup. Okay, I don't know exactly why they called it Beautiful Soup, but it's a very nice HTML parser. Unfortunately, it does not come bundled with the nthought Python distribution, so you'd have to install it separately. So I'm not going to talk about it too much. I can answer more questions about it afterwards if anyone wants to know. But you can also, it's a good way to get practice installing third-party applications packages. We didn't talk about too much. I'll talk about this element tree. This is in the LXML package a little bit more. The basic idea is that the element tree provides a class that makes it more convenient to handle any XML. XML is called extensible markup language, of which HTML is one particular incarnation of that. And it creates each tag, it treats as an individual element. That element can have attributes like the text associated with it, the name of the tag, and there are also methods that allow you to look for children, parents, and search through individual element trees. And the nice thing about this is that it maintains hierarchical relationships that are intrinsic to any HTML page, and you can access children with normal list syntax in Python. So here's just sort of what this looks like. Again, if you've seen HTML, this should look largely familiar. But all HTML pages start with, at least all well-formed HTML pages should start with this HTML tag, which is up here at the top. This tells you that the web page has started. Underneath that, as a child, there are going to be two sub-branches, one of which is the header, the head tag. You can see it starts right there, and it ends with that backslash there. That just contains some basic background about the page, like if you want to give it a title or any other sort of meta information. And then the other branch off the main root HTML is the body. This is what's actually going to be rendered by your browser. And so you see there's a header is one of the branches off the body, and then the table is the next one, and then below the table are rows, and each row has several columns. So what we're going to want to do is sort of traverse down and grab the data in the individual columns down here corresponding to a given row in the table. So to do that with this element tree package, we're going to, from LXML, import the element tree. I said before we had this big string, which is just our HTML file in one long string format. We're going to tell it we're going to use the HTML operated on this string. What this returns in this object here is basically this element tree object, which is a long, you can think of it sort of like as a list of objects of all these different tags. there's this elementary object has a method called find. And find, what we're looking for is this is telling it to look either at this level or any level below this level for a tag named table. Okay, so we're going to grab all of the tables that are located within this HTML page. We're going to cycle through those and extract the useful information because we sort of know how this is built. We're going to see if the name of the object is equal to the first column in that table, the text attribute associated with it. Then we want to grab the information from it. This is where we get the coordinates, where it is on the sky. I'm just doing some simple replacing because astronomers they don't like blank spaces. They like to put colons in between their coordinates like that. This is the host galaxy, which is contained in the third column in the table, and the type is in the fourth, and then return that to the user, assuming that we found a match. If we go all the way through and we don't find a match, we'll return none, which is not in here, but it's actually in the code itself that I sent. Okay, so this is a really simple example of how you can parse through an HTML page, assuming you know something about how it was created to extract some information. Once we have that, we need to know who we want to send this information to. A nice way to store and retrieve this information is in what's called a relational database. The sort of standard for this now are databases that are created using the structured query language, SQL, MySQL, PostgreSQL, any of these things. Basically, all these are sort of very fancy ways of sticking tabular information together and allowing you to search through that in a very efficient way. So the standard example of a relational database is an address book, company, address, city, state, zip code, phone number, all of that. And these these structured query languages allow you to store information in these databases, which can be very large, and retrieve it in a relatively efficient manner. So we're going to use SQLite 3, which is nice because it's small. It interacts nicely with Python. It's not extremely powerful, but that's okay. We don't have a huge database. It gives you this sort of built-in SQL syntax access to it. The database is going to be stored actually just as a normal file, which is not necessarily true if you're dealing with like a MySQL database, or you can even store it in memory if it's small enough. So the syntax is similar. The biggest problem is that it's not portable. If I have my database stored locally on my machine, that's an architecture-dependent thing. I can't just send that to you and you can read it. But again, for our purposes, this is more than sufficient. So if you haven't seen any SQL before, this might look a little strange, but it's relatively readable, so you should get a sense of what's going on. You can import this SQLite package. This is telling you what file name I want it to write it to. This is obviously unique to my local hard drive here. I'm going to connect to this database. If it already exists, this will actually throw an error. So it's good to check to see if that file exists first, which again, if you look at the script, you'll see there's a basic check for that. We're going to generate a cursor so that we can interact with this database. We're going to create a new table that we're going to call Astro People. And within that table, they're going to be the columns first name, which is a text item, last name, also text, email address, and status, whether they're grad student, postdoc, faculty, or whatever. And we're going to start inserting into that table some rows. So we can insert Josh in here as an email address. He's a faculty member. We can insert Adam Morgan, who you saw earlier has done several of the breakout session solutions. We know that he's a grad student. Go through all the people who are lecturing in this class. And then we want to actually commit our changes, which tells the database, all right, we're happy with what we've made. Please actually write this to the file, and then we can close it. Okay? So then if we want to query that database to get information out of it, again, it's a very basic SQL syntax. We connect to it, we grab a cursor, say, I want to look for any random student that's in this database. We don't want to pick on anyone too often. So going to select from this database, that means I want you to return the values associated with the first name, the last name, and the email address from the database name here, where status equals student, and then say order by random. Okay, so it's going to automatically, it would order it alphabetically, I think. In this case, I want it to do it randomly, and I only want you to give me one return. I don't really care if there are 100 students in there. I'm only interested in emailing one. Okay? So then I need to fetch the results of that query from the cursor. That's what this row gives me. If I actually look at what row looks like, it's a single item list that contains, in this case, a tuple with these 3 items that I asked it to return: first name, last name, and email address. This little U here before the string tells you that it's a Unicode string, just something about how that string is encoded. It gives you a little more characters than some other string encoding types. But it'll print out the same way given these characters like that. And then we can commit, even though we didn't make any changes, and close the file. Okay, so this is very basic. Again, easy SQL, if you ever worked in SQL databases, interaction with a database that's stored very locally on your machine. Unlike MySQL DB, you don't need a server up and running. You don't need any proprietary licenses for other fancier kinds of databases. Very nice to do that sort of work. Okay, and last, to send the email itself. Okay, you can guess if you want to import the email package into Python. How are you going to do that? You're going to grab something from the module named email. In this case, we're going to grab this thing called multi-mime part, which is just a way that email messages are formatted. Sort of sticks all the information, who you need to send it to, who it's coming from, the message itself, if you have any attachments, kind of gels them together into one nice, widely recognized package. We're also going to grab the way that text is formatted so that we can send a nice long text message to there. Since I'm actually going to send emails and I don't want to put my Gmail password up here, I have it stored in another module that I did not upload to the website called Nothing to See Here. And so that really will throw someone off the case if they're looking for it. I'm going to import that, and there's a variable in there called password that we'll make use of in a minute. So these two allow you to construct the email, and this SMTP-lib, Simple Mail Transfer Protocol library, allows you to actually send it to the required packages. So I have here the person that I want to send it to. I'm going to send something to Adam Morgan. I have his email address, first name, last name. I have the information that I want to send to him. This was all returned in some of the previous methods that I showed. The name of some object, what galaxy it's located in, where it's on the sky, a little more about its type, my email, where this is coming from, and we're going to create a new message, and this one's called MIME multi-part message. This creates a new message object that we can write to. This object has a couple of attributes, not properties, they're not strict attributes here. We can set the from property of this message to my email address. We can set the to the Adam's email that we want to send it to. We can construct the message text itself. So we want to personalize it a little bit. So we'll actually use his name in there. Hi, Adam. I just found out about this supernova. It's really neat. We don't know anything about the host galaxy. We'll say it's unknown. Otherwise, we tell them about the host. We don't know where it is on the sky. It'll be tough to follow it up, but that's okay. Otherwise, we tell them where it is on the sky. Something about the type. Adam also actually made this really nice, online Python script to generate an image of that field automatically. You just feed it the coordinates. So I'm going to make use of that, and I'll show you an example of that where we just input the coordinates and the name of the object to this web page, and it will automatically generate that dynamically. And then we say, could you please arrange some new observations? I'm really busy drinking right now, because that's what postdocs do, apparently. Sign it nicely, thank you. And then attached to this message, this string formatted as a MIME text. Okay, this is just all formatting so it knows how to send and receive the email. So we've created this new message. Now we actually want to send it. We create a new object called a mail server that we're going, in this case, we're going to connect to Gmail. We know which port we want to talk to. This is a pretty standard port for the SMTP client that's running on that. We start the authentication protocol. Gmail wisely won't just let anyone send emails from their server. We log in with the email address and the password that we have for my account. And then from the server, we just send the email. Okay, we send the email itself, which is this big object, the address, and we can format the message as a string there. And then if we're nice, we'll close, talk to Gmail. Okay, so that's basic 3 things. I wanted to show you putting it all together. We can write a routine called do science. It takes one required argument, the name of the object we want to look at, the file name for the database, the URL, where the additional information is, and the email address, all as keyword arguments. So we want to see if this database exists. If not, create it. Select the random graduate student to do our bidding, and find out the additional information from the website, and send the email. Okay, faculty job, here we come. Excellent. So let's see if this actually will function properly. So I have in this directory both of these Python files. This appetite.py is what is up on the website there. It has essentially all the routines that I showed you on the slides, including this do science here at the end. The nothing to see here has my password. There's the SQL file where this database has been stored, so it already exists. We can fire up Python. We can say import appetite. We've brought it into the namespace. Appetite.doScience SN 2012A. And it will grab the information, hopefully, and it says, all right, I emailed Chris Klein, and in fact, I did accidentally email Chris Klein, Adam Morgan, and several other people last night while testing it. But this time I actually meant to email him, so he can check and see if he got it. And just to show off Adam's nice little finding chart here, you can go back to the web that was automatically generated, and bring it up, and there's an image of the sky at those coordinates that I put in there, and it even has a nice, little contact information down here. I believe you can specify the name up at the top, and all that is generated dynamically on the fly. Okay, so finish there and take any questions. Yes.
How often do you use Python for?
So we work a lot with robotic telescopes, and in that case, a lot, because we want to say, oh, I observed this object for you last night. For me personally, I don't really use it all that often, but for that purpose, I do use the email package quite a lot. Go ahead. So there are capabilities to handle like gets and posts and all that stuff. It's just parsing it is not necessarily going to be as straightforward. you need to know something about how the website is set up, how the HTML is set up, if you want to extract useful information from that. But it's definitely possible to handle those. It's just a matter of how intelligently you can parse it. Yes?
When you're doing the SQL part, did you say that connect method only works on a pre-existing database?
So if what was I saying? It's a good question. No, that's not. I did say that, but that was wrong. So I'm sorry. It will allow you to connect, I believe, whether the file exists or not. It's just a question of I wanted to know if the file exists so that I wouldn't, whether I wanted to actually populate it with a new table and new information. That's why I was doing that checking there. Sorry, thank you for that. Yes?
Do you have SQLite on your computer, or does it come with that?
SQLite 3 comes with the nthought Python distribution, and that is everything that you need. You don't need any of the MySQL, server, client, any of that stuff. It's very small, compact, and very nice for very small databases for that reason. All right, well, I think Josh is going to give us a wrap-up now. All right, let me turn this on. Thank you guys all for sticking around. We're almost at the end point, penultimate session here. Again, I have my PDF of this up on the website if you want to grab it to follow along. I also have just the code that I'll be running. If you want to play with it, I didn't make a notebook because there won't be too much going on within the terminal for any of this. But the idea for this session was to do something a little bit different. You've heard a lot of scientific computing stuff today. You saw some nice work that James showed you just before that's actually relevant to his research. But I'm going to give you a slightly different perspective on how science is going on. Is this thing really interesting? What are the best resources we have to observe this? Or because I'm very fortunate in that I'm not really the sort of lowest tier of the totem pole, there are fortunately graduate students below me. I can get them to do the work for me. So we're going to write a Python script called DoScience here. It's going to extract some additional information about this source from a web page, just a short, simple one that I created for this. We're going to select a random graduate student from an SQLite database in the astronomy department, and we're going to send them an email to ask them to do the actual work. Okay? Simple, straightforward. Hopefully you'll learn a little bit about interacting with the outside world in Python. Connecting to the internet, the two modules that are very commonly used for this are called URL-lib and URL-lib done. This is from a postdoc perspective, if you will. And so also, hopefully, you'll learn a little bit about how you can use Python, not just for things like data manipulation, but how to interact with the outside world. So we'll talk about how to talk to websites in an automated manner with Python, in particular using these three modules. It's a little bit about relational databases using this one particular formulation called SQLite 3. So sending some basic email, again, all from Python scripts. And at the end, we're going to write a short Python script called DoScience. Okay, that's the output of this. So this is my somewhat biased perspective as a postdoc here at UC Berkeley on how science gets done. You should know I'm an astronomer. I'm going to use a few astronomers too. Both of them provide access to any uniform resource locator. URL-lib is more or less deprecated at this point. You really only, unless you're doing sort of very specialized things, be working with URL-lib2. And OpenURL, again, is this sort of very simple command. You'll feed it as an argument a URL page you want to grab, and it will retrieve that information, assuming you're connected to the internet. So here's a simple web page that I created. The URL is again at the top here. Has a list of recent supernovae, objects of interest. something about information about them in this little simple table, like where they are in the sky, what galaxy they occurred in, something about the type of object that they are. This is what the related words, but I don't think that will obscure the meaning for any of this. So usually I'm sitting around, working hard at my desk, and I get an email like this. Comes from some professor. It's got a subject saying supernova, which for all intents and purposes, some interesting astrophysical source that's not going to last forever. We have a finite time window in which we can actually observe this thing. It says, "Dear Brad, please arrange for further observations of this interesting source. I'm busy teaching or traveling or sitting on the beach. Thanks from your favorite professor." And then, of course, there's the sort of threatening, "I'll get you your recommendation letter as soon as I can," so you're really extra motivated to actually go out and do the work. So, I have a couple choices at this point. I could actually really try to put some time and effort into actually finding out what's